Welcome to the unit on quality assurance. This unit introduces apparel quality assurance and comprises of 3 modules and a final review section that invites you to reflect on what you have learned. By the end of this unit, students will be able to describe the different methods of maintaining quality in the apparel manufacturing industry, outline the standards and guidelines used in the apparel industry. The first module explains the importance of making quality measurable. The word quality has multiple meanings. Two of those meanings are critical not only to quality planning but to strategic business planning as well. They are product performance and freedom from deficiencies. In the sense of performance, quality refers to the performance feature of a product. Such features are decisive regarding product performance and product satisfaction. They compete with each other in marketplace. External customers, especially ultimate users, compare competing performances. Their comparison then become a factor in deciding whose product will be bought. Due to competition in the marketplace, a primary goal for product performance is to equal or superior to the quality of competing products. There is much demand for apparel with a very high quality in the marketplace. The word quality also refers to freedom from deficiencies, which takes many forms such as late deliveries, customer claim and returns, high rate of rework, even cancellation of sales. These are collectively forms of product dissatisfaction. Some deficiencies impact external customers and hence are a threat to future sales as well as a source of higher cost. Other deficiencies impact also customers and hence are mainly a source of higher cost. For quality in the sense of freedom from deficiencies, the long range goal is perfection. With this in mind, quality can be defined in different ways. It is constructing solution to problems before they occur and designing excellence into a product or service. The delight of the ultimate judge of how well products and services measure up. Quality is productivity from employees who receive training, tools, instruction that are needed to execute their jobs. It is willingness to change in order to meet demands. It is doing things quickly and correctly. It is a schedule being on time. It is the process of ongoing improvement. It helps in reap a payoff because in the long run, doing it right the first time is less expensive than correcting it later. Many companies require regular reports but take no action to bring about improvements as a result of those reports. A heavy focus is placed on measuring systems and methods instead of result and possible improvements. Measuring a process without improving it leads to increased costs and lower product quality. If all new product development costs are due to failures because measurements are not monitored and effective solution not planned. What gets measured gets managed. Conduct of the quality function depends heavily on the quantification of the product and process characteristics. The process of quantification is called measurement. The measurement results are dependent on standards being used. Improvement occurs when the measured results are monitored and compared against standards, resulting in actions. The measurement of current performance is essential for continuous quality improvement. What cannot be measured cannot be improved. There is no end to quality improvement processes when results are continuously monitored. Companies measure sell profit growth and other parameters to satisfy stakeholders. It is better to monitor the process that provides these results rather than measure the results alone. Results will follow when input is controlled and the process is monitored. A very effective control system is required to ensure that the whole product stream meets specification with only a tolerable amount of exception. Most companies follow the three-tier system of quality checking. The best results have been found to be achieved with the system, which are three components activities linked by a manager report. They are in-process sampling, 100% examination, and quality audit. These modules explain the importance of quality assurance in the garment industry. Quality assurance refers to the assurance to customers that our product, parts, components, tools contain specific characteristics and is fit for the intended use. In today's competitive industrial world, no business unit can exist for a long time without adhering to quality. Now, the assurance of quality is not the responsibility of a senior person or a department only. Only the inspection department or its personnel cannot be held responsible for assurance of quality. It is responsibility of everyone connected with production, directly or indirectly, and each department. Main objective of quality control are to identify and mark fabric faults on the fabric, to decide whether to cut the fabric lot or not, to increase productivity of the cutting department. Quality products require quality piece goods. Even the most outstanding manufacturing methods cannot compensate for defective materials. You can use these recommendations to help create an aggressive piece goods quality control program and eliminate many quality problems before the manufacturing process begins. Here are some inspection guidelines. The fabric store should always inspect the fabric as soon as it reaches the facility. Always store the fabric in a clean, moisture-free environment. As soon as fabric arrives, a swatch or of dimension as specified by the laboratory should be submitted to a laboratory to check the fabric for adherence of fabric performance standards that are required. Many companies prefer to undertake fabric checking while spreading. This is because while spreading, a spreader is concerned primarily with spreading the fabric, not to inspect the quality of the fabric. Let us now review important inspection standards to be followed. These are 4-point system: inspection of fabric meterage, roll size, selection of rolls, classification of defects, acceptance point count. The 4-point system is widely accepted in the textile and garment trade because it is easier to understand and implement. This system also lays down standards that are proven and acceptable in the garment trade. It is recommended to use same system while checking fabric. In the fabric meterage to inspect system, at least 10% the meterage is to be inspected. For a shipment or order of up to 200 meters, it is recommended that inspection should be carried out for 100% piece goods. For a shipment between 200 to 2000 meters, inspection should be done for at least 200 meters on 10%, whichever is greater. Roll size. For better utilization of fabric, it is suggested that there should not be more than 10 to 15% short rolls, that is the rolls of 20 meters or less in the order. Selection of rolls, at least one roll of each color, that is even if it exceeds 10% the total meterage should be selected. In case more than one roll per color to be checked, then select the number in proportion to the number of total rolls per color received. The 4-point system classifies defects as shown in the table. For 3 inches or less, 1 penalty point. For over 3 inch but not if over 6 inches, 2 penalty points. For over 6 inch but not over 9 inches, 3 penalty points, and over 9 inches, 4 penalty points. For holes and openings, for 1 inch or less, 2 penalty points. For over 1 inch, 4 penalty points. A maximum of 4 points is charged to 1 linear meter. Defects less than 1 inch from the selvage of the fabric will not be counted. Only major defects are considered. A major defect is a defect that, if conspicuous on finished product, would cause the item to be a second. A minor defect is a defect that would not cause the product to be termed as second either because of severity or location. Major defects are classified as major woven fabric defects, major knitted fabric defects, major dye or printing defects. Accepted point count. This method of acceptance used as a projection of total defects based on the number of defects found in an inspection of a sample. This method of acceptance uses a projection of total defects based on the number of defects found in an inspection of a sample. For example, the points are calculated on a 100 square meter basis. To calculate the average points, 100 square meters for the shipment. Total points counted for all roll inspected into 39 into 100 divided by total meters inspected into cuttable width in inches. Up to 40 points per 100 square meter is the acceptable defect rate. The objective of quality control in spreading and cutting are to ensure that all garment parts are cut as per the pattern, decide if garment parts have to be recut, increase productivity of the sewing room. Finally, this module provides useful suggestions and ideas that you can employ to ensure quality during the manufacture of garments. Spreading is not considered as important operation during garment manufacturing. It is normally carried out manually without the supervision of cutting master and is a critical checkpoint. A post-sewing measurement defects found in a garment can in most cases be attributed to incorrect spreading and cutting. While spreading, the quality assurance inspector should check the fabric lay for following defects. In case of a marker, always compare the marker with the original pattern. Ensure that all parts of a particular garment appear on the marker. Check for the smaller parts such as collars or cuff for their presence in pairs. Check that the marker is placed on the spread and edge is parallel to the selvage of the piece goods. Ensure that all cut pieces are complete. Check the table for all table marks. Allow no minus tolerance for splicing, that is a minimum of 1 inch of overlap. Ensure that the marker is not creased, damaged or has overlapped parts. Make a random check of some measurements in the marker. Sometimes while making a blueprint of the marker, unknowingly the marker gets pulled. This distorts the sizes. Ensure that the height of spread is at least 2 inch less than the cutting blade knife. In case of nets, ensure that ply height is stable. After completion of the spread, check the far edge of spread to see that all plies extend beyond the marker line. Ensure that there is no artificial or excessive tension due to a very tight spread. Also check randomly for any creasing of the fabric. Check carefully to ensure that one edge of the fabric is square to the tabletop. Visually inspect to ensure the alignment of the edge with the tabletop. Check the count after completion of spreading and before cutting. Count all plies at both ends. Ensure there is no tolerance. Often changes are made to markers to adjust certain production problems. Under no circumstance should such an act to be undertaken. In case such a situation arises, all changes should be made in consultation with merchandiser of the company or quality inspectors. Should there be any change required in the pattern or marker, a new pattern or marker should be developed. Under no circumstance should changes to be made on the same marker. Under no circumstance should any tolerance to be allowed in the spreading or cutting, as such a defect would lead to accelerated defects while sewing. The spreading inspector should inform the spreading master or cutting masters of the irregularities in the spreading and ensure that corrective steps are taken. In the case of re-spreading or redevelopment of the marker, the inspector should decide on the date along with the spreader and informed quality inspector of the company. When inspecting, always try and inspect without disturbing the cut block. This is essential in case of the particular piece has to be recut. Don't disturb the order of the cut pieces as they have not yet been numbered. These are some of the important inspection standards to be followed. Number of parts to inspect, selection of garment cut parts, defect classification. It is recommended that at least 50% of the garment parts in marker to be inspected. Parts cut on different types of cutting machine are to be taken in the ratio of 1:1. This is recommended so that it takes care of both the small and big parts of the garment. For example, the big parts of a polo shirt are cut on a straight knife and small parts are cut on band knife. For purpose of inspection, the parts chosen for medium size would be front, back and sleeve for the straight knife and placket, yoke, half moon, cuffs for the band knife. In case of all garment parts are cut on one type of cutting machine, the parts selection should be combination of both the big and small parts. In case there are a lot of measurement problem observed in the sewing room, it is advisable that all garment parts to be checked in the cutting room. In case of particular problem in measurements such as under or exceeding tolerance, as evidence from past records, quality team of a company should check all the garment parts in the cutting room as per the recommended system. Defects can be classified in a number of ways. Check for miscut or for the failure of cutter to split the line. This is a judgmental defect. For certain parts such as pockets, collars, ragged cutting can be a critical problem. Whereas for some parts like the front, the defect would be less severe in case of ragged edges are not too severe. The notch location should be checked by placing the pattern over the top ply. Defects can be further classified in these ways. Check pattern, slant knife, measurement checks, excess wastage of fabric. Compare the pattern to the marker to ensure that the marker was correct. Check the top and the last ply for the slant knife. This occurs while cutting when the knife blade tilts and results in a difference in sizes throughout the ply height. Tolerance for straight knife is 3 mm, band knife 2 mm and die cuts 1 mm. The quality inspector should try and assess the wastage of fabric in cutting. It is a situation where excess wastage is found. For the example, and uses the inspector should make a note and discuss it for the senior management. Quality control sewing. This system describes how monitoring the quality is an ongoing process and not merely a control mechanism. The approach of this method is to be proactive rather than corrective. The entire system revolves around building quality into the garment and not inspecting quality into the garment. Sewing defects begin and end with the operator. It has been noticed that in most cases, the operator is not aware of what is required from him or her in terms of stitching quality. It is thus imperative that one sealed sample, that is a sample as per order, correct fabric and trims, be available and easily accessible to all operators at the sewing floor. In case of certain garment parts that require a skillful operation or for a critical operation, the operator should be given a sample to the same for their ready reference. The broad objective of this is that there should never be any legitimate reason for someone not knowing what is happening. The three-part system is suggested to be used in the sewing room. The components of three-part systems are in-process sampling, 100% inspection, quality audit. Sampling is more economical and feasible than checking everything. A proper sampling system can give results that are closely representative of actual situation. Attention can also be focused on areas where defects are being produced. The objective of in-process sampling are maintaining a steady and tight control over all operators and concentrating attention where poor quality is being produced. The inspector should be a person not directly responsible for the production. The inspector should have adequate knowledge of the garment being produced in terms of tolerances, stitching details, workmanship quality that is required and manufacturing standard for the garment. The quality inspection sheet should describe the parts or parts that are to be stitched together, the workmanship quality pertain to that particular part, for example, a straight seam or a curved one. Any quality problem that might occur at their particular operation, the tolerance pertaining to their sewing operation. This information should be available to operator at their workstation where it is easy to read. It should be legible, that is, it should be neat and if required in the local language. It is responsibility of the supervisor that each operator understand his or her specification clearly before production starts. Depending on the results of the check, the whole bundle is accepted as being of satisfactory quality or rejected as being unsatisfactory. The rule which decide what constitutes a satisfactory or unsatisfactory bundle are laid down as a part of factory's system. Accepted bundle should proceed to the next operation where the rejected bundles are passed to the supervisor for auction. Checking an operator's quality. When the operator has been cleared, he or she is not checked again until her name comes up in the normal random sampling procedure. In this way, the inspector keeps checking an operator whose quality is bad while still going around the factory checking other operators. Of course, neither the operator nor the supervisor is expecting to calmly allow an operator to remain uncleared for quality for long. The supervisor will speak to the operator on the first rejection and should take urgent action after a second rejection to find out what is wrong and cure it. An important point of this system is that at no time does the inspection return the work directly to the operator. Only the supervisor returns work for repair. The operator is responsible for that particular section and should review all work that is being returned. The operator will then judge the reason for the defect and take appropriate action dealing with operator, machine or cut work. The supervisor and the inspector. The ideal situation is where the supervisor feels that inspector is there to help her by finding quality problem for her before they become serious. This attitude must be introduced from the start when installing a sampling system. The supervisor should be educated to see the inspector as a helper, an extra pair of eyes, not someone there to create trouble. Unless the supervisor and inspector cooperate, the system will not work. Apart from this relationship with the supervisor, the inspector must be able to understand what is being looked for. The inspector should also interpret quality specification and have sufficient confidence in her own judgment to insist that a mistake is a mistake. Even when the supervisor says that is not bad, it can go on. There are 4 parameters that need to be defined before starting in process sampling. The collection of garment or parts from where the sample is to be taken, the number of garments or parts to be taken for inspection from the lot. For example, 6 garments from one bundle of 25 pieces. The number of faulty garments or parts that a sample may have without the entire lot being rejected. For example, 0 out of 6. If there is even a one defect piece in the sample, the entire lot will be rejected. The number of lots that must be accepted in succession to take the operator out of clearance procedure. For example, 1 lot. 100% examination is the check to all stitch parts and some garment parts in production. 100% examination should be within the line and at the end of the line. The objective of 100% inspection is to prevent defective garment from being passed, repair faulty garments and remove the cause of the defects, prevent faulty garments from being passed as perfect. It is likely that after the in-process sampling, some faulty garments will be produced. The examination stage. Examination is a stage in the production sequence and is normally regarded as an operation. Most factories examine at end of making operations and sometimes at the end of finishing. In another factory, examination is combined with thread trimming. On one hand, the trimmer is going over the seams anyway and you may as well examine at same time. On the other hand, trimming and examine call for different types of operators and some operators tend to trim and forget to examine. Whether or not these operations are combined depend on personnel of the factory. Examination points. For economic reason, there should be a few examination points as possible. On the other hand, for easy repairs, examination points should be placed before any operation which oversees an earlier one. For reconcile these opposing objectives, it should be considered how many defects are actually being produced by each operation, how many are found at the examination point, and whether or not these defects will be visible in the finished garments. The usual position for inline examination points is after a critical component has been made before attaching it to the main garment. For example, after making a shirt collar. Inspection guidelines. The inspector should be trained to inspect. This implies that there should be a predefined set of action that is undertaken to examine each garment or parts for visual and measurement and workmanship. Examination tends to be a boring job and many inspector can become mesmerized after a while and simply not see what is being looked at. To help avoid this, an operator description must be written for this job, detailing how the inspector should check the garment. The inspector should be positioned within the line similar to a sewing operation. The inspector should have a workstation that is adequately large to handle the garment parts that is to be checked, as well as the reports and other work aids that are required to carry out the inspection. The inspector should have adequate authority not to send a bundle to the next operation in case fault are found. Under no circumstance should an inspector be harassed by the operator to pass on the bundle just because the production target for the day has to be met. Quality audit is an examination of a small number of garments from the finished stock from sewing. These are taken as a representative of quality that is going to be finishing room. At end line, checkers are audited individually 4 times a day to ensure control on checking efficiency of end line checkers. The objectives of a quality audit are to check the other parts of the system, obtain figures which can be compared with figure of in process, sampling and final inspection, giving comparisons of the effectiveness of above two systems. Look at garment from the customer's point of view and analyze results. Inspection guideline. The auditor for the sewing floor should be a qualified and experienced quality controller and should be able to check a garment thoroughly as per buyer's specification. The auditor should himself randomly pick the garments from each checker's past pieces. These pieces should not be given to him by supervisor or any other personnel. He should audit each checker at least 4 times in a day in order to get a representative checking efficiency of the checker. This is the formula for checking the efficiency of a checker. Checking efficiency is equal to 100% inspection DHU into 100 divided by 100% inspection DHU plus quality audit DHU. For the washing or finishing audit, emphasis should be given to areas affected by washing or finishing, such as trimming, holes and fraying at the collar due to washing. Quality audit is an everyday process and should be undertaken without fail. Quality control in finishing. It is recommended that 100% inspection and an audit to be carried out either after washing or finishing. In case the wash process is rigorous or a special wash is being done, it is advisable to check all garments after washing. It is recommended that the garment should be slightly ironed and then inspected. The main objective of 100% inspection is to identify defects that occur after washing. When inspecting, emphasis should be on those areas that are affected by washing, such as button attachment and fraying of collar. The inspection could be combined with thread trimming in case of normal washes. It is recommended that the garment be ironed lightly before inspection. This eases out the creases from the garment and aids the inspector in identifying defects. Finishing quality audit. Finishing quality audit and examination of a small number of garments passed by checkers from finished stock. These are taken as representative of the finished quality going to customer as first. It is recommended that daily quality audits are conducted to ensure consistency in quality. It is acceptable to inspect a small number of garments thoroughly. However, under no circumstance should the audit be missed or its results overlooked. The main objective of the finishing quality audits are to check the other parts of the system and to obtain figures which can be compared with figures of 100% final inspection. This will give comparison of the effectiveness of above system. Finally, it allows an inspection to be done from the customer's viewpoint and to analyze results. Inspection guidelines. The auditor for the checkers audit should be a qualified and experienced quality controller and should be able to check a garment thoroughly as per the buyer's specification. The auditor should himself randomly pick up the garments from each checker's past pieces. These pieces should not be given to him by the supervisor or any other personnel. He should do the audit and any checker at least 4 times a day in order to get a representative checking efficiency of the checker. Pre-shipment quality audit. Quality audit is an examination of small number of garments from finished stock. A quality audit is recommended to be followed after packing of goods begins, and audit should be conducted daily to ensure that the shipment is of consistent quality. These are taken as representative of the finished quality going to customers as first. The main objective of the pre-shipment quality audit are to check the other parts of the system, obtain figures which can be compared with figures of in-process sampling and final inspection, giving comparisons of the effectiveness of the above two systems. Look at garment from the customer's point of view and analyze result. Guideline. The auditor for the quality audit should ideally be from the senior management and should try and scrutinize the product from the buyer's point of view. The auditor should himself randomly pick up the garments to inspect from the day's production. These pieces should not be given to him by the supervisor or any other personnel. Quality audit is an everyday process and should be undertaken without fail. The following points must be checked for conformity with standard. Carton size, oversized carton are not allowed. Carton quality, this includes the carton gross weight as well as net weight. Carton tape, carton should not have factory or the vendor's name and address printed on them. The following points must also be checked for conformity with standard. Carton's marking should be clearly marked. Unsorted or broken pre-packed carton numbers packing list must show all the details. Packed quality, packing size ratio in a carton, all garments to be packed along with the individual polybags. Finally, check that loose pieces are not packed. The type of fold according to packing instructions. For correct barcoded ticket with correct placement, use of scanners to read the barcodes, size clips that are present if required, hang tag positions, adhesive size strip placement, garments for workmanship, fit and measurement quality as per the washing audit. You have come to the end of this unit. To summarize, in this unit, you have learned about in-process sampling, 100% sampling and quality audit. You have also learned about quality assurance for raw materials, spreading and cutting, sewing, finishing and packing. You have also been given an overview of inspection standards and guidelines for various stages of manufacturing process. You have now reached the end of this course. Thank you.